You think those are LEDs there? Yeah, they're probably LEDs. They're pretty cold. LEDs are a lot more efficient than incandescent lights. How do LEDs work? Light-emitting diodes, how do they work? How does the light come out? So LEDs, it's just a semiconductor, right? So you've got two pieces of silicon, and one of the pieces of silicon is doped with some atoms that have an extra electron, and the other half is doped with some atoms that have a missing electron. And that means that there's extra electrons on one side and missing electrons on the other, and the electrons jump across the boundary to try and balance it, and then a charge builds up across that, and that's how a diode works. And then when you forward bias a diode, when you pass current through a diode, you get this effect where electrons fall into the holes on one side, and there's an energy gap between the electrons and the holes. And as they fall, it shakes the electromagnetic field, and a photon comes out. And that's why light-emitting diodes emit light. What you may not know is that all diodes emit light. They don't have to be light-emitting diodes. All diodes emit light because there's always a little energy gap between the electrons and the holes on each side. When I was a boy, I played around a lot with electronics. And electronic equipment is relatively expensive, so I would try to buy my equipment from surplus stores. And there were surplus stores that would sell old electronic components, and I would buy a bag of 100 diodes. Half the diodes wouldn't work. So what I would have to do is get all 100 diodes and put them in a pile, and then I would build myself a little circuit, and the little circuit had a little place where I could put the diode on. And the circuit was a simple circuit. It was a battery and a light and two nails in a board. And to complete the circuit, I'd put the diode across the nails. The light would light up if the diode was forward biased, and it wouldn't light up if it was backward biased. So I'd take the diode and I'd flip it over, and I should see the light light up or the light not light up. And then I could toss them into two piles, those that work and those that don't. But every once in a while, doing that, I would get a diode, a regular diode, and I'd put it across the contacts, and it would light up. It would glow orange. And I thought, well, that's really weird. I was like 18 years old. I didn't know what the heck was going on inside there. But the reason that was happening is because the manufacturing of those diodes was not real refined. It wasn't very accurate. So from time to time, they would build a diode that just had an energy gap in it that allowed light to come out. I didn't know that, but I thought it was pretty cool. In those early days, they didn't want the light to come out because that was a waste of energy. And then somebody realized that it might be a really good idea to have the light come out. So then they figured out ways of increasing the energy gap so that red light came out. Does anybody remember when red LEDs first came out? Right? Yeah, that was cool, right? Because all of a sudden we had these new ways to light up panels and stuff like that. And we had red LEDs everywhere. Remember the very first digital watch? This would have been 1975. 1975, the very first digital watch, the Motorola Pulsar. And it was black like this, but you could touch the button, and a 7-segment red LED display would light up, telling you the time, and then, of course, it would go back to sleep, just like my current watch does. Some things don't change. It didn't take long for green LEDs to show up. It was about 10 or 15 years when the green LEDs showed up. And the reason it took that long is that the researchers were trying to figure out what chemicals they could use in the diode that would stretch the energy gap high enough to emit green photons. That was not an easy problem to solve, but they eventually got green light to come out reliably. And what you've got here, this is actually two LEDs. One's red, one's green, and when you mix them together, you get this nice orange color. Well, what we started seeing then was all of these red-green signs, and they would go alternate between red, green, and orange, because they could turn on both colors at the same time. So you saw lots of displays in stores that had red letters and green letters, and then they'd mix them and get orange. That was very common. It took a lot longer to get blue LEDs, because the energy gap is really big. And the researchers struggled for a very long time to figure out what materials they could use and what chemicals they could use to get that energy gap to grow to a blue photon. But they eventually got blue photons. And all of a sudden, we had all three primary colors. And we could make LED panels and LED displays. And look at that thing. You know, my watch has got red, green, and blue LEDs on it. My screen, my iPad's got red, green, and blue LEDs on it. And these LEDs, they're so efficient. So you burn, those lights up there have got to be 1,000-watt lights. Well, they might be LEDs. No, they're not. I already said they're not. I looked at them with the diffraction grating. They're not LEDs. So it's probably a 1,000-watt bulb in there. How many watts would it take to light up an equivalent LED? And the answer would be about 10 watts. No, about 100 watts. They're about 10 times as efficient. Right? And that's why I can walk over to these things and touch them, and they're not very warm because they don't use a lot of power. I have outfitted my house with nothing but LED light bulbs. All the light bulbs in my house are LED light bulbs, and it makes me smile. You know, I turn on the lights, and they're all LEDs, and I go, yeah, it's really cool. You know, it's all quantum mechanics is lighting my house now. Yeah. And my wife, God love her, grew up in a household where the father always said, turn off the lights. And now I tell her, honey, there's no power being used here. It doesn't cost it. Turn off the lights. Well, what can we say, huh? So our last talk of the day, there's supposed to be two talks, but I'm mixing them into one, because why the heck not, you know? The last talk of the day is all about Agile. We're going to talk about Agile. Maybe. Yes, okay, that looks good. Are we all right? Yes, we're good. Okay. How many of you are doing Agile? That's everybody, virtually. Okay, what kind of Agile is it? And I noticed, by the way, you know, there were hands in the air, but they were kind of going. Yeah, so, okay, fine. What kind of Agile is it? Is it Scrum? Or Scrum Butt? Or Scrum Fall? Or XP? Somebody doing XP? XP. Stream programming. What's your iteration size? I think I asked you that, right? 2 weeks? Everybody doing 2 weeks? Good? Okay. Well, so why do we do Agile? What is the reason? What is Agile? What does it mean to be Agile? So before we can answer those questions, we have to go through some of the external reasoning. How do you manage a software project? Now, I've put some answers on the board up there, and I imagine some of you have experienced a few of these answers. Those are the wrong slides, so let me get the right slide up. There it is. Now, the first one up there, probably everyone has experienced. How do we manage a software project? Badly. Another very common approach is hope and prayer. You know that this is the approach in use if you can see two parallel lines dug into the carpet by the manager's desk as he prays to God, I hope this project actually works. And one of the really common techniques is to dictate and motivate. We dictate by telling everyone how bad it's going to be if we don't deliver this project. And then we motivate everyone by hanging pictures of people climbing rocks and seagulls flying over the ocean. And that'll get the project done. Now, the reason that we need to have a way to manage software projects is that mismanagement has some severe costs. So, for example, if you mismanage a software project, you will build the wrong product. Who's done this one? Work for 6 months, deliver a product, have the customer look at you and say, what the hell is this? Good. That's mismanagement. The project has been mismanaged. Right? The managers have failed to manage the project properly. They delivered the wrong product. Another symptom of mismanagement is to produce a product of inferior quality. Who's done this one? You work for 6 months and deliver a pile of crap. Okay? Well, that's bad. That is mismanagement. The project has been mismanaged. Has anyone ever been late? You know, that always works. Right? That is mismanagement. Right? A software system, if a software system is late, it has been mismanaged. It is a management problem, not a development problem, a management problem. The last one may not apply here. I don't know if you guys work stupid overtime hours like we do in the United States. In the United States, it is considered a badge of honor to have worked an 80-hour week. It shows your dedication to the cause. I don't know if you guys do that, but it's certainly a mismanagement issue. If you are forced to get a software system working by working tons and tons of overtime, there is a management problem. Now, why is it so hard to manage software projects? What is the fundamental cause of this? And the answer to that has been known for a very long time, and it's actually a very simple problem. Good, fast, cheap, done, pick any three, you're not going to get the fourth. This is called the Iron Cross of project management. All the project managers know it in the room. Any project you do can be good, fast, and cheap, but it won't get done. Or it can be done cheap and fast, but it won't be any good. Pick any three you want, the fourth one you cannot get. By the way, this is just a fundamental law of any project you do. Right? You cannot take all those things and get them all. So a good manager has to look that square in the eye and decide how to adjust the knobs. How good, how fast, how cheap, how done. And a good manager will do that by adjusting the knobs with lots of feedback to drive the project to the best possible outcome. That outcome may not be what was originally targeted. You start a project with all kinds of dreams and hopes. By the time the project is over, you may wind up in a very different place, but at least it's a good outcome. And that would be a successful project. Now, if you're going to drive a project to a successful outcome, to the best possible outcome, what you need is data. If you're a manager, you got to know what the heck's happening in there. What happens? You ever had a manager walk into the team room and ask the team, how's this project going? What's the answer? Pretty good. You think there's any data in that? Think the manager's gotten any insight into how this project's really going? And everybody on the team is sitting there, yeah, pretty good, pretty good. Don't tell them anything. So there's no data coming out of that. We need to find a way to get data. Well, how do you get data? Well, what kind of data do we need? Wouldn't this be great? This is a chart on the wall. And the chart shows how much got done every week. And what does it say up there? It says story points. Well, what are those? I don't know. Some number. Doesn't matter. What if you believed it, though? Now, this team got 45 points done that first week. And the week after that, it was like 42 maybe. And the week after that, it was 50 points. And the week after that, it was 40 points. And if you look at that, you kind of study it for 10 seconds to say, well, you know, this team is getting around 45 points a week done. Next week, they'll probably get around 45 points done. Over the next 10 weeks, I think they'll probably get 450 points done. This is really useful information if you're a manager. Because now, if you're a manager, you can start to predict things. You can look ahead. You can say, hey, this team is getting about this much done every week. Okay, and then there's another piece of data that would be really useful. That's a burn-down chart. Burn-down chart says there's about 500, isn't it? About 500 points remaining until the next major deliverable, the next release. And every week we see that number go down a little bit. You're kind of hoping it's going down by 45 points a week, although maybe it is, maybe it isn't. But at least you can look at that chart and notice that the chart has a slope to it. And that slope lets you project out and say, oh, this thing's going to be done in May. Now, you don't know if that's good news or bad news. The manager does, right? If you're supposed to deliver in June, that's pretty good news. If you're supposed to deliver in April, that's really bad news. Right? But at least you know, right? At least you're a manager and you know, oh, shit. Now, what happened on February 17th? We wound up working for a week with more to do. And you said scope change. It's certainly possible. Maybe there was a requirements change. Do the requirements change? Of course they change. It's the software, remember. Of course, we want the requirements to change. Any software team that freezes the requirements is making a terrible mistake. No requirements freezes ever. We don't want the requirements to freeze. We want the customers to change the requirements as soon as they know that the requirements need to change. So, okay, maybe that's what happened there. And we want to know it as soon as possible so we can put it on the chart and everybody gets reset what their expectations are. But the other possible reason that that bar is a little bit higher is that the developers looked at the project again and realized that their estimates had been wrong, and so they re-estimated, which is perfectly acceptable because they're estimates, they're not promises, and therefore we want to know as soon as the developers realize, our original estimates we're a little optimistic, we want to know that as soon as possible so everybody understands what's happening with this project. Put these two charts on the wall. Anybody can walk into the room where those two charts are, look at those charts for 10 seconds, and say, this team's getting about 45 points a week done. I think they're going to be done in May. That's really powerful. Of course, May might not be a great number. You might have wanted it done earlier than that. Well, that tells you you're not going to get there. This is Agile. The reason we do Agile is to get these two charts on the wall. You got these two charts on the wall? Some of you do. The rest of you? If you don't have those charts on the wall, you are not producing the data that the managers need to know how screwed they are. The purpose of Agile is to destroy hope. Some people say, we're doing Agile so we can go fast. Agile does not make you go fast. It doesn't slow you down either. It doesn't change a thing about how fast you go. Agile is just a way to produce data so that you know just how messed up things are. And then you can manage. We want to know as soon as possible how messed up we are so that we can manage. Because there's this thing that managers do. It's called managing. We want to be able to manage the project to a good outcome. There's a question right here. Ooh, I get to throw this thing again. No. No. Okay, ready? Yeah. Okay.
The first one, I think the team is responsible for. But the second one is the product owner or manager. I mean, the team doesn't know. The team needs to be fed with all the stories done. In my environment, they don't know it yet. They know it for 2 months in advance, but not for 5 months. So, is it the team responsibility then?
So this is the second chart there, is the burn down chart, which tells us the number of points until the next major deliverable.
Okay.
Right? So that deliverable has been planned. Did you know that in Agile you plan out about 3 or 4 months? Right? You're looking at all the iterations and thinking, well, these stories in this iteration and those stories in that iteration, and we kind of think maybe it'll take another 5 iterations for these stories. All that planning is done. By the way, that planning is done virtually every iteration. So every iteration we create another 3 or 4 month look ahead. Yeah, where are we going to be in 3 months? All that stuff is very variable, but we do that. And does it mean that we're not going to introduce new requirements in the midst? No, we do. You can see it right there. New requirements came in. New stories got added into the schedule. That's fine. This is Agile. This is the purpose of Agile. The purpose of Agile is to get these two charts on the wall. If you don't have these two charts on the wall, you are not doing Agile. You're doing something else. Now, do the charts have to be on the wall? Could they be in somebody's spreadsheet somewhere? It's better to have them on the wall, because then everybody can see them, and everybody can know how screwed they are. And that's a good thing. So I'd like to see those charts on the wall. What are those points? Well, before we talk about the points, let's talk about projects. What's the first thing you know about a project? Before the project has a name, before there are any requirements, there's one piece of data you have about the project. It's always the first thing you know. Yes, thank you, the date. And that's for very good business reasons, because there's a bunch of guys who sit in a room and they say, man, we got to have something by November. Don't know what it is, but it's got to be by November. Because there's a trade show in November. We've got to be at that trade show. Or there's a shareholders meeting in November. We got to be at that shareholders meeting. Project's got to be done. Something's got to be done. Or, and this is a good one, we run out of money in November. This is a good business reason. And engineers, the developers often scoff at this idea that the business people create these arbitrary deadlines and force them to meet arbitrary deadlines. What you don't understand is that those deadlines are actually real. And there's real consequences behind them. So you cannot scoff at the business deadlines. They are real business deadlines. They have real reasons behind them. Yes, there are sometimes managers who set false deadlines. That's immoral. But most do not. Most are setting real business deadlines. There's real teeth. Now, the date is frozen. There's no point arguing about the date. It's a hard business date. The requirements are not. The requirements are changing. At first, we don't even know what the requirements are. Later on, we'll get an idea what the requirements are, but they're going to change all the time. And why are they going to change all the time? Well, because the customers don't really know what they want. And the more we talk about what they want, the better idea they kind of get about what they want. But they really don't know what they want until they see something execute that is not what they want. And then they say, oh, no, that's not what I wanted. So we're going to have to get things out in front of customers very early so that they can tell us, oh, that's not what I wanted. I know it's what I said I wanted, but now that I see it, that's not what I want at all. We need to be able to start that cycle very, very fast. This is the environment of software developers. It is an environment where dates are fixed, requirements are not, and somehow we have to drive the project to a good outcome. Now, this is an old problem. It's been around ever since software's been around. And there was a guy who wrote about it in 1970. His name was Winston Royce. And what he said, he wrote a very famous paper, Managing the Development of Large Software Systems. And in that paper he said, wouldn't it be great if you could break the project up into 3 major phases? And in the first phase, we would analyze all the requirements. And we'd put a date on the end of that. And when we got to that date and we had analyzed all the requirements, we would know that we were 1/3 done. And then we would design the implementation. And we'd spend the time designing the implementation, and we'd put a date on the end of that. And when we got to that date, and when the design was complete, we would know that we were 2/3 done. Wouldn't that be great? Now, Winston Royce wrote that in a paper. A lot of people agreed with him, too, and said, yeah, that'd be great. So here is the picture that appeared in Winston Royce's paper on the first page of Winston Royce's paper, in which he made this case. Wouldn't this be great? And in fact, the case he made was, this is how it's usually done. This is how software is usually done. Now, notice the the flow of arrows down those blocks. It looks like water rolling down rocks. It's called the Waterfall Model. What Winston Royce went on to say in his paper is that that doesn't work. Because as soon as you get to the testing phase, you realize the design phase is all screwed up. And as soon as you try and touch the design, you realize that the requirements weren't properly analyzed. And you've got to really go around that loop over and over again. And actually, the only way to really get anything done is just to do them all at the same time. Apparently, no one read that paper. Because the picture that appears in the process documents of the time that companies and countries adopted is just that one. They took the first page. They assumed they knew what he was saying. They copied it into their documents and said, this is the way software has to be done. This was 1970. Now, I was a young programmer in 1970. I'd been a programmer for a year or two, a professional programmer for a year or two, professional in quotes. And I remember when the articles started appearing in the trade journals about this new idea of dividing the project up into an analysis phase and a design phase and an implementation phase. And I remember thinking, oh, good, some way to get some resolution on how to build a software project. I was thrilled by the idea. I was a young man. I was thrilled by this idea. And thought, yeah, some way to get some hold on a software project. A lot of other people felt the same way, apparently. And we started building software that way. So now I'm going to take you to a meeting. This is a meeting that would have occurred in the 1980s or the 1990s. Big boss calls us into a conference room, says, all right, got a new project to do. You're all off your old projects. You're going to be on this new project. We don't have a name for it yet, don't have any requirements. It's got to be done November 1st. Now, how long will it take you to do the analysis? We don't have any requirements yet. Right? No, you're professionals. You've been through this before. I don't need an exact number, just a date to put in the schedule. Keep in mind, if it takes any more than 2 months, we might as well not do this project. 2 months? Good, that's what I thought too. Now, how long will it take you to do the design? We haven't analyzed the... No. You're professionals. You've been through this before. Keep in mind, if it takes any more than 2 months, we're not going to do the project. What do you say? 2 months? Good. That leaves us 2 months for implementation. Thank you for coming to my meeting. Who's been to that meeting? Enough of you. The rest of you count yourself lucky. Because this is the way software was scheduled in the 80s and the 90s and unfortunately well past into the 2000s in many companies. So now, you leave the conference room, you go back to your desk, what are you doing? Oh, you're analyzing. Well, what's that? Something. Now, the great thing about analysis is that you can read books on analysis. There's a load of books on analysis. And you can get all those books and you'll read them and you'll find that they all say different things. People do not agree on what analysis is. The best definition of analysis is that it's what analysts do. But that's what we're doing for 2 months. We're going to do that for 2 months. So this is a good time in the project because you can spend your time day trading and talking to some customers and writing down some notes and figuring out requirements and playing little games about, oh, what if it did this and what if it did that? And you're doing all this kind of flurry work. And then suddenly it's July 1st. And what's the status of this project? We're done with analysis. Why? It's July 1st. We don't want to be late, so we might as well be done. The great thing about analysis is you never know when you're done. There's no way to tell when you're done. There's no closure criteria. There's no definition. So you might as well be done on July 1st because you certainly don't want to be late. And you have a big celebration, balloons and speeches as you pass through the phase gate into the design phase. Everybody's on time. This project's on track. This is the first big lie that the process tells you. All right, now what are we doing? Now we're doing design. Now we know what design is. Design is pretty well defined. Right? We're going to be breaking the requirements up into modules, and we're going to be designing the interfaces of those modules, and we'll be breaking the organization up into teams and figuring out the manpower of those teams and how they're going to communicate and how the modules will communicate and all this very interesting work during the design phase. Meanwhile, of course, the requirements are changing, and we'd like to go back and reanalyze those requirements, but we really don't have a lot of time here because there's only 2 months, so we kind of hack those new requirements into the design. But that's okay because the design keeps coming out and we're drawing diagrams and breaking things up and doing really fancy work. And then it's September 1st. And we're done with the design because it's September 1st. Because design is one of those things that you cannot finish. You don't know when you're done with design. Analysis and design are not Boolean deliverables. They do not have two states, done and not done. They are simply open. So now we're done with the design. What are we doing now? Another speech, balloons and speeches, happy day, the project's still on track. If only we could do it one more time. If only we could just say we were done with implementation. And I know many of you have tried. But there is something about implementation that actually has to be done. So now we start the implementation phase. What are we doing in the implementation phase? It's completely clear what we are doing in the implementation phase. We're coding. And we better be coding like mad banshees, too, because we've blown 4 months of this project. So now we're down there writing code like crazy, writing code. Meanwhile, the requirements are changing, and you'd like to kind of reanalyze them and redesign them, but you don't really have time for that. So you hack them into the code. And meanwhile, you kind of look at the code that's coming out, and you compare it to all those design documents, and you realize you were smoking some really heavy stuff when you did that design, because the code coming out doesn't look anything like that, but you have no time to deal with that because you've got to code like crazy. Code. Sometime around October 15th, some developer sticks his head up above the cubicle and says, hey, what's the date? Oh, man, you mean we got to deliver this in 2 weeks? There's no way we're going to deliver this in 2 weeks. And somebody goes and tells the stakeholders, and you think the stakeholders are pleased? Can you imagine the stakeholders? I imagine you can imagine the stakeholders' reactions. You've probably experienced the stakeholders' reactions. What do you mean you cannot deliver? It's only 2 weeks before the deadline. Couldn't you have told us during the analysis phase? Couldn't you have told us then that you were going to be late? Weren't you trying to figure out how long this was going to take? Weren't you doing the estimates during the analysis phase? What about the design phase? Couldn't you have told us this during the design phase? Weren't you sizing the modules and doing manpower analysis? Why did you have to wait until 2 weeks before the deadline? And they've got a point. So now the project enters the death march phase. And morale goes into the toilet, and everybody's trying to get something done, and nobody's happy, and the executives are throwing their hands in the air, and the customers are all upset, and nobody's happy. And sometime in March, you deliver some limping thing that sort of half does what the customers want. Everybody is upset about this. You come out the back end of that, and you go, Jesus, I never want to go through that again. Next time, we're going to have to do it right. We'll do more analysis and more design. Now, I call this runaway process inflation, right? You take the thing that didn't work and you do a lot more of it. So here's Agile. Agile comes along and turns this on its head. It says, wait a minute. Here's an Agile project. That lower right-hand corner is a date. Let's say it's November 1st. First thing you know about a project is the date. That doesn't change. What do? Well, we take the project, and to the best of our ability, we cut it up into a bunch of fixed time boxes. Those vertical slices there are all fixed time boxes. Let's say they're 2 weeks long. All right, so we know what the end date is. We know what today's date is. We can calculate how many of these boxes we've got, how many iterations or sprints we've got. We say, all right, well, that's going to be our project. Now, what are we going to do in that first sprint, that first iteration, first 2 weeks? Some people call this iteration 0. And what we're doing there is we're gathering some requirements, not all of them because we can't get them all, but we'll talk to the customer a little bit. This is when we're writing use cases, or nowadays we call them user stories. We're writing user stories. And I'll talk to you a little bit about user stories later, but a user story is usually just a word or two on a card. Don't need much. Certainly don't want a lot of detail yet. Detail comes later. So we just want to kind of have a reminder, a little card that reminds us of what this feature is. And the features should be relatively small. And we'll talk to the customers, and we'll write down cards, and we'll write down stories, and we'll get our source code control system working, and we'll fiddle around with some design and architecture ideas. We'll go to whiteboards and draw diagrams and try and figure out what the gross architecture of the system is. Don't want too much detail yet because we haven't really written any code. But we kind of want some idea of the shape of the system and the module breakdown and so on. We're doing kind of traditional design and architecture and analysis work for one iteration. And at the end of that iteration, we've done that for maybe a week or two, then we start real implementation. Now, we might have actually done some real implementation in that first sprint, but very often you don't have the time to do that, so okay. In the second sprint, we begin doing some real implementation. What are we doing? Well, we kind of make a guess about how much we can get done in that sprint. So we say, we can get feature 1 or feature 8 and feature 12 done in that sprint. Okay, so we start to work, and we're coding, and of course those requirements are changing on us, but those requirements are getting shuttled into this deck of cards that we're creating, so that's okay. And we're writing code, and by the end of sprint 2, the first sprint we're actually coding, did we finish everything we said we'd finish? No, we're programmers. We never finish everything we said we'd finish. What are you, nuts? No, we didn't do that. We just wrongly estimated everything. We only got a little bit done. But okay, now we know we got a little bit done. We did get a little bit done. Now we know how much we can get done in one sprint. And we write that down, and we do a little math. And a little bit of math says, we're screwed. Oh, yeah. Looks like we're going to be done sometime in March. That's not good news. But you see those brackets there, those are the error bars, the statistical error bars. Now, they don't hold out a lot of hope for us either. But, maybe the next sprint will go better. So we start the next sprint, and things do go better. Yeah, the source code control system is working a little better. That little architecture idea we had is actually working, sort of. We refine it a bit, because we're always at the board refining the design and refining the architecture. There's diagrams on the board and diagrams on the walls and stuff like that. We're always doing that kind of work. We're also coding, making more stuff work. And by the time we get done with the next sprint, we actually did a little bit more than we did in that first coding sprint. Maybe we'll do that a few more times, and by the time we've got, 3 or 4 sprints done, we can do that math again. And now there's no point in hoping. We're just not going to make November. It's not going to happen. Now, by the way, this is early in the project. It's only been about 5 sprints, 4 sprints, 5 sprints, something like that. Maybe a month and a half gone by. We already know. No, sorry, not going to happen. We're going to have to manage this project somehow. So what can we do? How do you manage the project? Well, there's a bunch of options. Remember the iron cross of project management, right? There's 4 things you can manipulate. So let's take a look at those 4 things. We could go to that top knob, the schedule knob. Go to the stakeholders and say, hey, stakeholders, do you mind if we don't deliver until March? Now, they might not like that, because they had a really good business reason why November was the date. So it's very possible that the stakeholders will say, what? No, we need this in November, not March. Can't be March, it's got to be November. However, I will say that if there is a time to change the schedule, this is it, because it's still early. They may have made no promises yet. They may have made no plans. If they're going to a trade show in November, they may not have purchased the booth space yet. If they're going to a shareholders meeting in November, they may have made no promises to the shareholders yet. And if they're going to run out of money in November, well, they got a little bit of time to get a bridge loan maybe. So early is a good time to tell everybody you're going to be late. Now, I'll tell you a story about this. I once ran a group that delivered a product to telephone company executives. It was a long project. We were going to be doing it for a long time. And we began it, and we told them, we gave them a date when we thought we'd be done. We came back a few months later, and we said, we're not going to be done then. We're going to be 6 months later. And this group of telephone company executives stood up and gave us a standing ovation for telling them that we would be late, but giving them enough time to prepare. You should not expect that. But it did happen to us. Now, maybe the schedule can't change. Okay, schedule can't change. Well, there's another knob there, the staff knob. Everybody knows we can go twice as fast by doubling the staff. Right? Just double the number of people, we can get twice as much work done. That works every time, doesn't it? Of course, it doesn't work because doubling the staff does not have the effect of doubling the throughput. What really happens is that when you add new people to the project, the old people slow down enormously. The whole schedule begins to slip because the new people suck the life out of the old people. And you kind of hope that after a month or two, the new people get smart enough to start getting faster. And even if that's true, it's risky as hell. And besides that, if you add more people to the project, it's going to cost more money. So maybe there's no budget for that. So let's assume that we can't change staff. Now, I have changed staff. Right? I have run a project, and we realized early on in that project that there was no way we could make the deadline, and the deadline was really important. It had legal consequences to it, and so because it was early enough, I was able to add a few more people to the project, and yes, we slowed down for a while, but yes, we sped up, and we were able to bring the deadline in a little quicker. Does work. If you can do it early enough, it does work, but it's risky, it's expensive, so let's assume that we can't change the staff. Okay, there's that knob at the bottom, the quality knob. Everyone knows you can go much faster by producing crap. So, you know what, guys? I know you want to write tests and everything, but we're really under the gun, so you're going to have to scrap all that testing stuff you're doing. You're spending too much time in code reviews. Kill that, because we just don't have time for that. And I don't want anybody, following any kind of process anymore, because that just takes too much time. I just want you to code. That's a really good way to make everything slow down like crazy. I've already talked to you about how you go fast. You go fast by going well. This is a bit in your head. It's a single bit. One bit. It's in your brain. If I could find it in your brain, I would flip it for you, but you're going to have to flip it for yourself. And this bit says to you, the only way to go fast is to go well. When you flip that bit in your head, by hard experience usually, you will realize that that knob has to be set as high as it can possibly set all the time. Quality is the only way to go fast. So we're not going to touch that knob. And that leaves one other knob to turn, which is scope. Maybe, just maybe, some of those requirements that we were planning on didn't really need to be there by November. Maybe the customer could live without some of those requirements for a while. So let's talk to the stakeholders about that and see if we can live without some of these requirements. Stakeholders, we can't deliver all of this by November. We can deliver some of it by November, not all of it. So you need to take some of those out. No, I can't take any of it out. We need it all by November. Well, yeah, but we can't give it to you all by November. Look, here's our math. I don't want to see the math. I just want it all by November. Yeah, but no, there's no way we're all... By the way, this argument can go on for a very long time. And although the stakeholders have the moral authority and the pure righteousness, the developers have the data. And if you work in a rational organization, I leave it up to you if you do, the data must win. So at some point in a rational organization, the stakeholders will say, all right, I should have hired a bunch of different people, but I'm stuck with you. All right, I guess we don't need that 1 second from the end. You can get rid of that one. You're going to give it to me later, aren't you? Yeah, we'll give it to you in December. We just can't give it to you in November. All right. You get rid of that one. And that one in the middle, you can get rid of that one too. You know, that 1 second from the beginning, it's a real shame you did that one because we sure don't need it. That's bad. Yeah, we don't want to hear that one again. We never want to, invest in work that we don't need to deliver by the date. So from now on, every time we start a new sprint, we're going to the stakeholders and say, which one of these do you want us to start next? We don't care. We're programmers. We can deal with all the weird stuff like you want log out before you want log in. That's fine. We can do that. Because we're programmers. We can figure that out. Just tell us what you want first so that we never, ever deliver something you don't need. That's Agile. That's Agile at the 30,000-foot level. Agile is a simple technique. You take a project, you subdivide it into time boxes, you measure how much you get done in those time boxes, you use that measurement to project the end date, and then you manage and manage and manage because every software project is always a horror scene. They're all going to need some kind of management because we don't know how long anything is going to take, really. Anybody here good at estimating? Yeah, there it is, 6 months. Why aren't we good at estimating? What's the problem here? Why can't we estimate software? We can estimate other things. Why can't we estimate software? How long does it take you to tie your shoes? Seconds? How long would it take you to write the instructions to tie your shoes? You can't even begin to estimate that, can you? You're going to control some robot, some Lego Mindstorm thing. You're going to write the code to tie shoes. How long would it take you to write that code? You can tie shoes. This is the problem with estimates. We have to tell a moron how to do something that we can do intuitively. We're going to produce a report about, bank interest. Oh, it's stupid. It's simple. Anybody could do it. A kid could do it. If you want me to write that report for you, I'll write it by hand. It'll take me a day. Okay, write the code for that. I can't even begin to estimate that because I can't begin to estimate how to write the instructions to tie my shoes. Same thing. It's the same problem. We don't know how long this stuff takes. Now, we can make guesses, and I told you yesterday about the 3 numbers, the 3 estimation numbers. That's helpful, but you should never forget that those are really wild estimates. They're just guesses. The guesses get better with time, so as you go along, from slice to slice to slice to slice, you get better and better at those estimates because you start reducing the variables. And that's another reason why those graphs can have little bumps in them. Our estimates promises. They can never be promises. Never be promises. You cannot promise to deliver fixed scope by a fixed date with fixed quality and fixed cost. You can't do that. That's the Iron Cross. The best way to manage that situation is this. Do it in lots of short cycles. Get the bad news as early as possible. And make no mistake about it, that is exactly what Agile is for, is to get the bad news as early as possible. It's not to go fast, it's to get the bad news early. The disciplines of Agile are on the screen here. These are the Agile disciplines. They come from a process that was called extreme programming from long in the past. Extreme programming was one of the Agile methods. There have been several over the years. Scrum is another, feature-driven development is another, Crystal is another, DSDM is another. There's a whole bunch of them. But the best defined is extreme programming. It's the one that defined all of the different parts of an Agile project. The green outer ring, those are the business-facing practices. And that's Scrum. The green ring is Scrum. Scrum, as an Agile process, is a business-facing process. It doesn't deal with the internals much. The red inner circle, that's the engineering practices, the programmer-specific practices. And the blue stuff in the middle, those are the team practices. That's how a team behaves. Those are the disciplines used by a team. Scrum is just that outer ring. Scrum, without the inner rings, has a name. It's called flaccid scrum. Scrum that fails. And what are the symptoms of flaccid scrum? Flaccid scrum starts to work initially just fine. You go through a few sprints, everything seems to be fine, the team is making good decisions, there's good communication with the product owners and so on, everything's going along fine. And then you start to see the team slow down. And the team gets slower and slower and slower with time. Why does this happen? Because they're not practicing the engineering practices in the middle. The engineering practices in the middle are the things that keep the architecture and the design and the code clean. And without that, Scrum will slow down and grind to a halt. It turns out that Scrum is a really efficient way of making a mess really fast, unless you augment it with the engineering practices in the middle. Now, this has been known for 15 years. The name flaccid scrum was invented by Martin Fowler 15 years ago. It's been a well-known term. Most Scrum teams nowadays adopt the engineering practices. Some don't, and that's a problem. So let's walk through these practices one bit at a time. I'm not going to get to them all. I do want to get to the green ones, because the green ones are the most interesting from our point of view. And I've already talked to you about test-driven development. I've talked a little bit about refactoring, so the stuff in the middle we can bypass for the moment. The practice on the far right is called the planning game. This is mostly what Scrum is about, the planning game. So let me describe how this works. We're sitting, the developers and the stakeholders together in a room. We're one small team. Agile, by the way, is a method for small teams to do small things. Agile is not a technique for big teams to do big things. It is a method for small teams to do small things. If you want to do big things, you have to use a lot of little small teams. And all the small teams are doing Agile. Some people worry about things like Agile in the large. I'm not sure there is such a thing. There is Agile in the small. That's how Agile was first defined, and it was the goal of Agile, to solve the problem of small teams. Can you do Agile in the large? I'm not even sure I know what that means. Can you get many small Agile teams to build something big? Sure. Sure. But do you have to use Agile to do that at some greater level? No, I don't think so. We've known how to get small bunches of teams to work for years. You know, we built pyramids. We went to the moon. We know how to do that kind of thing. So Agile was just about small software teams doing relatively small things. So here we are. We're a small software team going to do something relatively small. And we're sitting with our stakeholders, and we start to have a discussion. What does this system have to do? Now, let's say that we're building the software for an automated teller machine. So we start talking about the requirements. And the stakeholders say, well, customers need to be able to get money. Okay, so you mean you want to be able to pull money out of the slot? Yeah. Oh, that means you're going to have to enter your bank account, right? Yeah. And the amount of money you want to take out, right? Yeah. And you better be able to identify yourself, maybe with some kind of a card and a PIN number or something like that. Yeah, okay. And by the way, that whole identification thing, you're going to need to do that for just about everything, aren't you? Yeah, well, that's probably a different story then. So let's deal with that story. We should call that story login. Login. Okay, done. Now, we don't talk about the details much. Oh, we might discuss them verbally. We might have a little discussion about cards going to slots and pins getting typed in and stuff like that. But there's not a lot of detail that we really discuss yet. And what we put on the card is just the word, login. That's enough. That'll remind us. Remember, this is a small team doing small things. Oh, we need to withdraw money. Well, how do you do that? Well, first of all, you got to log in, and then you enter your bank account, and then you enter the amount you want, and it's going to spit money out of the slot. It might jam, a bunch of old problems there. Okay, well, what are we going to call this? We'll call it withdraw. Withdraw. Some customers are going to want to deposit money too. Well, what's that money going to be in? Well, they'll put it in an envelope. Well, where do they put the envelope? Well, there's a slot for it. Okay. You're going to shove an envelope in a slot. How do you know who the envelope belongs to? Well, we'll print something on it. Okay. So, deposit. Yeah, that's a good card. This is the process. That's it. Bunch of people sit in a room. They have a little conversation about what the requirements are, what ought to be done. There's some details discussed. They're not written down. We'll get to that later. For the most part, we're just writing these things on cards. And by the end of a day, we got a deck of cards. Now, it's not complete. More cards will be put in later because every couple of days we're going to sit down with the stakeholders again and say, hey, what else do you want this thing to do? And they're going to add more cards to it. And they'll come to us from time to time and say, oh, we need it to do this and that and this. More cards go into the deck. We wind up with a little deck. Anybody here using cards? Oh, good. What else would you use? Is anybody using Jira? Do you say to yourself, have you done your Jiras? I've heard people talk like that, right? Like the name of the product becomes more important than what you're doing with it. Have you done your Jiras yet? That tells me there's a symptom of a problem somewhere. Like maybe the tool has become more important than the function. But never mind that. Why wouldn't you use cards? Well, we're programmers. We automate everything. Well, yeah, but why wouldn't you use cards? Oh, we got to have everything in computers. Fine. Put it in a computer if you want. I don't care. But here's what I'll say about that. World War II was managed on index cards. I believe the technique scales. By the time, a few days have gone by, we've got this nice deck of cards. There's no estimates on them. We don't know how long these are going to take. So then we have a little sit down with the QA people and the developers and our team. What is our team made of? There's 5 developers and there's a couple of QA people and there's a manager and there's a product owner and that's the team. And the product owner actually is a part-time member because the product owner is a product owner of probably 3 different teams and that kind of thing happens and that's fine. So we sit down with the team and we start estimating. And mostly it's the developers and the QA people who are doing this. And say, okay, log in. How long is that going to take? 3. 3 what? I don't know, 3. Just put a 3 on the card. Well, is that the right number? Yes, because it will take 3. Now we know how long login will take. It'll take 3. But that's interesting because now we can compare withdraw to login. You say, no, wait a minute, how hard is withdraw? You take the card, read it into the slot, read a PIN number, compare them, spit it out of the slot. There's a bunch of stuff to do. Okay. Well, what do you got to do for withdraw? You got to enter in a bank number and an amount, and you got to spit money out of the money slot, and that might get jammed, and that's harder. And the developers all look at that and say, that's harder than login. 5. Okay. 5. What about deposit? You got to take an envelope in and print on it. Ask him for his bank account, I guess. That's not as hard. That's 4. 4. That's the process. That's the estimation process. And it's quick and it's easy, and we use a number of different techniques for this. One of the techniques is called flying fingers. And flying fingers works like this, right? All the developers, the people who are estimating, they all sit around a table. Somebody puts a card down and says, okay, what do you think about withdrawal? And we talk about it a little bit. We say, okay, withdrawal is, money comes out of the slot, it might get jammed and stuff like that. And then somebody in the room says, okay, everybody, what's the estimate? And everybody puts up some fingers behind their back, and then somebody counts 1, 2, 3, and all the fingers come out. Now, if they're all a 3, what was it for withdrawal? 5, right? If they're all a 5, then everything's fine. But if you see around the table there's a couple of 2s and a couple of 5s, well, then there's a discussion to be had. And so we have that discussion. Why do you think that's a 2? It's a lot more complicated than login. I don't think it's more complicated than login. And they start to have a little discussion. And then eventually the discussion ends and somebody says, okay, let's try that again. 1, 2, 3, okay. And you come to some consensus that way. It's called flying fingers. Some people like to use planning poker cards. Fine, you can use those if you want to. Sometimes those planning cards are Fibonacci numbers. Great, whatever. But usually, a hand of fingers is good enough. You probably don't want to have more than 5. Story might be 1, might be 2, 3, 4, 5. That's probably good enough. Oh, this is probably a reasonable result too. Right? Like, I don't think it's going to take any time at all. And then this one is probably not a bad result. It's like, I don't know. That's a good result because then you can have more discussion. So now, we got a deck with a bunch of estimates in it. Are those estimates right? Login is. The rest of them, well, they're okay, because relative estimates are better than absolute estimates. Programmers are better at doing relative estimation. Everybody is better at doing relative estimation. So, okay, we've got some estimates. Now we begin the first coding sprint. First coding sprint begins with a meeting, iteration planning meeting. Should take half an hour. Meeting starts. Stakeholders say, programmers, how many cards are you going to get done this sprint? How many points? Programmers go, 30. You sure you can get 30 done? No. Why'd you say 30? Well, you wanted a number. We don't know. 30. So now the stakeholders pick out cards that add up to 30. Login, that's a 3. Yeah, that's pretty important, but 3 is expensive. That's like 10% of the budget, so we're going to wait on that one. Log out, 1, cheap, do it. Right? Yeah. Deposit, 4, that's expensive. Put that one aside. Withdraw, that's really expensive, 5. But I want to see the money come out the chute. You're going to do it. This is the process. Right? The stakeholders are drawing from this card, and they're making a cost-benefit comparison. How much value do they get for the cost? And they don't need to know what the real cost is. They don't need to know what 3 means. They just need to look at it and say, oh, okay, that's kind of expensive. It's 10% of the budget. All right, well, am I going to get value for it? We're going to wait. It's a pretty simple return on investment calculation. Good product owners go through the deck and select the highest value cards that have the lowest cost. And that's kind of cool. And they'll pick out 30 of them. Points that add up to 30. Okay, the rest of the deck just sits over here. Now we got cards that add up to 30. And now we begin the process of implementing those cards. I will talk about that process later, perhaps, because we don't have that much time. But overall, the process looks like this. One by one, the cards move from the ready pile to the done pile. Now let's say we've got a 2-week sprint. We started it on Monday. So the following Monday is the midpoint of the sprint. How many points should be in the done pile? 15. Yes, to do this process, you must be able to divide by 2. Monday morning, we have a little meeting. How many points are in the done pile? There's only 8 in there. We're not going to get 30 done, are we? If we're lucky, we'll get 16 done. Better call the stakeholders. Stakeholders! We screwed up, man. We said 30, but we don't think it's going to be more than 16. Why don't you take, you're going to have to take 14 points out of the pile. Said, what do you mean? You said you'd do 30. Yeah, but we're halfway through the sprint. We've only got 8 done. We're not going to get any more than another 8 done. You got to leave us 8. Leave us the most important 8. And of course, the stakeholders are very upset by this because a full week has gone by, and man, that's a lot of wasted time. But okay, they go through the pile and they leave you with 8. And by some miracle, On Friday, you're actually done with those 8, and you've gotten 16 points done. And now you put a little bar chart on your velocity chart, and you say, 16, all right, we know how much we can get done in one sprint. And what do you do as the next sprint begins? Next sprint begins, there's a nice little iteration planning meeting, should take about a half an hour. Everybody sits in that meeting, and the stakeholders say, how many are you going to get done this sprint? 16. That's what we got done last sprint. We'll do 60. Well, you said you could do 30. Yeah, but we got 6. All right, they pull out 16. The 16 highest value points they can get. Now we begin to develop them. And on the Monday, the midpoint Monday, there's 12 points over there. Things have been going better. Should we tell them? They're coming to the meeting, right? It's the midpoint Monday. They're coming to the meeting. They're going to look in the done pile and say, hey, man, you got 12 points over there. You're going to get 24 points done this iteration. And they're going to come and give us a few more cards. And Friday comes along, and we don't get all 24 of them. Then we got 20 of them done. All right. So a little disappointing, but all right. And so we start the next iteration. What do we say? Stakeholders say, how many points you want? 20. We got them done last time, give us 20. Now, this is the process. This is how it goes. Right? Round and around the loop. You just measure how much you got done every sprint. That's what you say you're going to get done the next time. It's not a promise. It's not a guarantee. It's just a little, help. Yes? Where's that thing? Who's got that thing? Throw it. Go.
So why not to take for the third sprint 20 plus 16 divided by 2 instead of another estimate?
Oh, well, if you want to do that, you can. If you want to do some kind of, complicated numerical analysis and calculate, fine, fine. Do that. The point here is that there's a lot of noise in this signal, right? You're going to paint these bars on the velocity chart. You're going to see a 16, and then a 20, and then a 12, and then an 18. It's going to go up and down a lot. You'll have to go through several iterations to really see what the signal is. But the signal will be there. So, it might not pay to do a really deep calculation there, but you can try that if you want. What's happening to this deck? It does grow. Because every day we're adding more cards to it. Stakeholders say, hey, we should do this, and we should do that. Programmers go to the stakeholders and say, hey, did you think of that? Oh, that's a good idea. Stick that in the deck too. So the deck is growing. What's coming out of the deck? High-value cards. Cards that have high value for low cost. High return on investment cards. That's what's coming out of the deck. What's going into the deck? All kinds of cards. Some of them have really high return on investment. Some of them have really low return on investment. We're not doing that calculation early on. So the deck starts to get low in return on investment. The more time goes by, the more the return on investment begins to drop away. There comes this magic moment. You start the next iteration. Stakeholders are there. Stakeholders look at the deck. There's nothing in here worth doing. Project's over. Project's not over when everything's done. Project's over when there's nothing else worth doing. And the stakeholders acknowledge, there's nothing else worth doing. It's remarkable what cards are left in the deck. I once worked on a project where the very first card ever written, the card that gave the project its name, was never played. It just stayed in the deck because there was always more urgent stuff to do. And by the time the project was over, this had lost all importance. It's remarkable what remains behind. Can an iteration fail? No, iterations do not fail. It's impossible for an iteration to fail because an iteration's job is to produce data. And even if you produce nothing, you have produced data. An iteration that delivers no points is good data for the managers because, boy, something's gone wrong. Better deal with it. Iterations do not fail. If you say, we think we're going to get 12 points done this iteration, but you only get 6 done at the end, has the iteration failed? No. The iteration has simply given you data. Iterations do not fail. The number of points in the iteration is not a goal. You're just simply trying to measure how much you can get done in each iteration. Now, let's look at that velocity graph for a minute. What should the slope of the velocity graph be over time? Slow and steady, dead flat. We don't want it to rise, we don't want it to fall. But if you're a project manager, what would you like the slope to be? Going up. That would be good, wouldn't it? If you're a project manager, you want to see that slope go up, because that means you're getting more done with time. How can you get that slope to go up? Guys, we got 20 points done last sprint, but I believe we can do 22. I know, with a little extra effort, you can get 22 points done. Think of it as a stretch goal, guys. Get 22 points done. Now, here's the thing that'll happen. They will get 22 points done. But how will they get 22 points done? By putting slightly different numbers on the cards. Because remember, these points aren't anchored to anything absolute. So they will begin to, and nobody does this intentionally, right? It's not an intentional thing. You just know you're supposed to get 22 done, so you're writing numbers on the cards, and humans are what humans are. They will write numbers that will fit. The next sprint might not be 22, the sprint after that might not be 22, but a sprint coming up is going to be 22. And the project manager is going to go, yeah, I've got the formula. I know how to do this. Guys, you did 22. Can you give me 24? Now, this drives an inflation spiral. You come back to that team a year later, they'll be doing 1 million points per sprint. You do not want to see a positive slope on the velocity curve unless you can explain it with something like, yeah, we added 3 people to the team. Now, that would be a reasonable explanation. Jim finally figured out how to make the database work. That'd probably be a reasonable explanation, right? But you don't want to see a positive trend. Because a positive trend probably means that someone is putting pressure on the team. And pressure on the team is going to shift all the numbers. So don't want to see pressure on the team, especially that kind of pressure. What would it mean if the velocity chart is going down? Sprint by sprint by sprint, less and less and less gets done. There's a mess. Somebody's making a mess. The engineering practices are not being followed. Not enough tests, not enough refactoring. Design and architecture are beginning to fail. And you want to catch that real early. However, that one is complicated by the other effect. Because as the developers start to make a mess and they realize they're going slower, or they don't realize it, but they feel it, they start to shift the numbers on the cards to flatten out that velocity. So the way we combat that is this. It's very simple. That login card that was a 3, you keep that one around. And you're always comparing against that golden login card. Whatever that card was that you said was a 3, you're always comparing against that, saying, okay, how does this compare to login, which was a 3? You try and anchor it against that card. You try and do that for as long as you can. It is 3:30. We have a half an hour left. In that half an hour, I want you to ask me questions. Oh, God. I've been here for 2 days. I've been talking my guts out. Yes, sir. Microphone.
So every time we deal with this Scrum process, I constantly start hearing at some point that, okay, we need to put on the cards acceptance criteria and definition of done, and then like it doesn't become card anymore. Like, and of course, because in most of the cases there's Jira, then it's very easy to write a lot of stuff in Jira. So
it's really easy to write a lot of stuff in Jira, isn't it?
Yep.
And it's great because nobody reads it. So it was a good question. Let me answer the question for you. What we initially write on the cards are just a couple of words, right? Just enough to remind us. A story might be a sentence or a small phrase. And we purposely ignore detail early on. But what happens in the iteration planning meeting, that half-hour meeting at the beginning of each sprint, which, by the way, is not a half hour. Usually it's about an hour or hour and a half. Depends on how long the sprint is. Right? 2-week sprint, 2 hours probably for the iteration planning meeting. During that meeting, the details are discussed. Now, who provides the details? Well, the business product owner is talking to people, and business analysts, if you happen to have them. But the real details come out of QA. QA are the people who are specifying the way this system ought to behave. In discussion with the business analyst, with discussion with the product owner, QA is the one writing down the acceptance criteria, the definition of done. Now, they don't write it down in some detail on the card. They might write a couple of notes on the card. But then the QA people go off and they start writing acceptance tests. Executable, automated acceptance tests written in some language that the QA people can deal with. This doesn't have to be, a programming language. If your QA people are programmers, then make it a programming language. That's fine. But their job then is to write the acceptance tests that will define done for every story. Programmers will know that they are done with a story when the acceptance tests for that story pass. That's how you know you're done with a story. The acceptance tests should be written during the sprint. They can sometimes be written a little ahead of time, but I don't want to get there yet. They're written during the sprint. We want all of the acceptance tests finished by the midpoint of the sprint, so that the programmers have enough time to finish their stories and make sure they all pass. The only stories that can rack up points in the velocity are points that pass the acceptance tests. So that's the basic flow. If at the midpoint you do not have all the acceptance tests written, it means you don't have enough QA people, or you've got too many programmers, one or the other. So it tells you you've got a staff imbalance. Now, if it's a temporary staff imbalance, a couple of the programmers can jump the line and help finish off the acceptance test. That should take about a half a day. If that repeatedly happens, well, then you probably ought to add a QA person, or maybe make one of the programmers a permanent QA person, or something like that. But it helps you balance the staff. Did I answer your question?
Yeah.
Good. Hand it right over to him. She's right there. Good. I'm only going to answer questions in this row here. Good.
How do you deal with non-functional requirements? Do you also put them in the car tag?
How do you deal with non-functional requirements? Was that your question?
Yes, and how do you tell the stakeholders that they are also important?
Okay, so how do you deal with non-functional requirements, and how do you tell the stakeholders that they're important? There are two kinds of non-functional requirements. There are those that the stakeholders are aware of. For example, the system has to be fast. Now, that's not a good story. System has to be fast. That's not a good story. So you have to get the stakeholder to put some numerical value on this. Like, we need to be able to handle 1,000 transactions per second. You can write a test for that. QA people can write a test for that. So that's a non-functional requirement that you put a number on that you can actually test. That kind of makes it a functional requirement, doesn't it? The other kind of non-functional requirement are those that are architecture related, architecture and design related. You never say a word about these, ever. This is like washing your hands after you go to the bathroom. You never, ever, ever go to stakeholders and say, well, we can get this done in 3 days if we don't do any architecture. You never do that. You never say to your boss, if I write tests, it'll take me 6 days. If I don't write tests, it'll take me 3. You never, ever say that. First of all, it's a lie, but second of all, it's dumb. You are the ones who know how best to get software done well. You have little bits flipped in your head that says the only way to go fast is to go well. You never, ever say anything about non-functional requirements like that to stakeholders. None of their business. It's part of how you do your work. You never, ever talk about refactoring. We've got to refactor. You never say that. Bosses don't want to hear that. What do you mean you got to refactor? Didn't you do it right the first time? Never talk about refactoring. You never put refactoring on the schedule. The word refactoring never appears on a schedule, ever. Because you're constantly refactoring. You're always refactoring. You're constantly improving things. So I presume that's what you were talking about. Good. Next question. Oh, this row. Look at that. You guys, sorry.
So it's not related to the topic of, but it's something that I mentioned to you before that I would love to hear more, because I read already what you have to say about mentoring. And I have this feeling that in the software industry, we miss a lot of people that have the skills to mentor others, especially developers. So I'd like if you could elaborate on this.
Certainly.
And if we could relate to the topic of today, then I would like if you could mention also about how mentoring could happen for product owners then.
What was that last word?
Developers.
Mentoring could happen for?
For the product owners.
Oh, for the product owners.
Yes.
All right, take that thing and throw it back there. As far as you can get it. Yeah, way back there. Go catch it. Go! Good. All right. It's in the lunchroom now. Mentoring. So mentoring is the responsibility of the most senior people. You know, the more senior you are, the more responsibility you have for mentoring, for teaching people who are younger than you are. Really, very senior developers should almost spend all their time pairing with other people. The most senior people should probably spend their time pairing with more junior people all the time. Mid-level people should spend a lot of their time pairing with junior people so that these skills can transfer. I know of one company where mentoring is cranked up to 11, right? This company hires apprentices, and they call them apprentices, and it's a temporary position. You may not actually get hired at the end of this process. You will be an apprentice for several months. During that period, you are not allowed to touch any production code. You are given some challenge projects, and those challenge projects are fairly significant, like you have to write a web server, and it has to be multi-threaded, and so on. And you can draw from your mentors. There are people attached to you who are your mentors. You can draw from them to learn how to do these things. Other challenges include giving a talk on some significant topic like a design pattern or a design principle, writing a blog about something, writing an article about something. Then these people, having met their challenges, will do a journey. And the journey will be through several different mentors where they will be pairing with those mentors at client sites, on client software, but never allowed to do it alone. And at the end of that process, which might be 3 months long, it might be 6 months long, the mentors all finally meet and vote. And it has to be a unanimous vote to let them become members of the team. That's an extremely high bar to pass. Should that be the way all programmers are admitted into our field? I leave that up to you, but I think that's an interesting concept. You who are senior, learn how to teach. And by the way, I'll tell you a little secret. The best way to learn something is to teach it. All you have to do is stay 1 page ahead. That's all you got to do. 1 page ahead, 1 day ahead. The best way to learn something is to teach it. So if you're a senior developer, start holding classes. Get a bunch of people in a room and say, all right, I'm going to teach you about, and pick a topic. And then just stay 1 day ahead of them. And you'll have enough experience and you'll have enough background to fill that with all kinds of useful information that the developers can take away. Wouldn't it be great if every organization had this classroom time where the senior people taught the younger people and the mid-level people taught the most junior people? I told you before that we have this real problem with the population distribution. Half the programmers in the world have less than 5 years experience. Well, this is one of the ways we deal with that lack of information. I hope I answered your question. Anything else I should say? Oh, you wanted product owners. Ha! Who are the best product owners? Best product owners are people who have been burned by bad products. Right? People who've been around the block a long time. Product owners should have a lot of experience because the product owner has this very interesting and very risky role. They have decided to put their head on a block and guarantee, using their head to guarantee that the product being produced will satisfy the customer. So it's a very risky role. It's a high responsibility role. This takes a lot of experience and a lot of, what's the best way to say it? A lot of failure. The best way you learn that kind of stuff is to fail at it really bad. Now, what's a good way to fail at it really badly? Be a business analyst. Right? That gives you room to fail because the product owner can always come in to backfill you. Usually the business analysts are trying to communicate what the product owner says to the programmers. Right? So that's a good way to learn how to be a product owner. Answer your question? Good. All right, who's next? Throw that thing to the nearest guy.
That's me, it's already here.
Yep, you got it? Okay, good.
Yeah, I've got a question about Scrum demos.
Scrum demos.
Can a Scrum demo define the end of a project? That the stakeholders say, we're done, this is good enough, we can ship it.
Yeah.
Really ship it.
Yeah. Sure, why not? You do, you know, it's the end of sprint demo, and everybody's sitting in the room, and you walk through all the features of the product, and the stakeholders say, yeah, ship it. Why not? I think that's a reasonable thing to do. Of course, all the tests have to pass. Now, that's one of the little things. And oh, by the way, who should be driving that demo? The product owner. Better than the product owner if the product owner invites a user in and then says, user, please drive the demo. Who should not be driving the demo? A programmer, a developer, because the developers know how to avoid all the crashes, right? You never let the programmers drive the demo. You let the users drive the demo or the product owner drive the demo. Next question. Heave-ho, yeah, look at that, that's great. Wow.
Hello. Can you hear me? Yep.
Yeah.
Okay. If you do a lot of analysis within a sprint, how do you estimate that? So if you do data analysis and those kind of things.
You mean data analysis of?
Well, in my case, it would be to predict something like customer behavior or those kind of.
Customer behavior. Oh, so your job in the sprint, so the story is analyze customer behavior.
Might be. Try to find a predictive indicator for customer.
Yeah, so you've got to come up with some predictive indicator based on customer data.
Yes.
Okay, is that a 3?
Well, to me, you can go on forever because it's analysis. So.
Ah, I see what you're saying. So you need some kind of resolution criteria. How accurate does this have to be? Right? And that's the critical number. I need to know this data within a 50% margin.
Yeah.
You ought to be able to estimate that.
Yeah, but
if I said I wanted it to within a 20% margin, well, you might have to, it might take you a lot longer. If I said I wanted it with no variation, 0%, well, that's going to take you forever. So when you're told, give me this data, you have to ask, okay, but what kind of resolution do you want? How much error can you tolerate? That's true of every estimate, by the way. Every estimate also has to be associated with an error bar. Did I answer your question?
I think so, maybe partly.
Partly?
Partly, sorry.
Good, okay.
To me, yes, some of it, it comes from the data, so you never know in advance.
One thing we sometimes do is called a spike. Let me define a spike for you. You've got a story, and you can't estimate it. And you've all had this thing, like you got to get the database to work. Well, how long is that going to take you? I don't know. And there's no story I can compare it to. I don't know how long it's going to take me to get the database to work. I'm just going to have to try. I don't know how long it's going to take. All right, then what you can do is you can say, let's define a spike. A spike is a period of time that you are going to try to figure out how long it's going to take to get the database working. Now, can you estimate that spike? I don't want to know how long it's going to take you to do the database working. I want to know how long it's going to take you to estimate how long it's going to take to get the database working. So now you've got a new story, and the story is to estimate getting the database working. And now can you estimate that story? Oh yeah, that's like a 3. And then after that story's been played, by the way, they may not play that story for a long time, because spike stories don't deliver any value immediately. But they eventually say, okay, we got to get the database working. Why don't you spend 3 points on figuring out how long it's going to take? And then at the next iteration, you say, yeah, that's going to be a 6. That's what a spike is for, to estimate another story. So that's another way you can do this data analysis thing. You say, okay, I need 3 points just to look at the data to try and imagine how long it's going to take me to actually analyze it. One more question. Throw that over here. All the way down here.
Hi.
No. All right, go ahead. All right. And then you can go, right? Yeah, okay. All right.
Advantage of close by here. As part of definition of done, how do we make sure to include migration script phase or NFR testing? For example, every project do not follow a kind of shippable product every sprint. They may do in a couple of sprints, for example. In that case, how do we include different test phases within the sprint? Do we follow with the hard and fast rule stating, okay, this is my definition of done?
Well, okay, so maybe you've got a process that says I can't run the tests in this sprint because of some reason, and I'm going to have to run the tests in the next sprint. And how do you deal with that? Well, you let all the stakeholders know that you're not going to be deployable that sprint. Right? You say, okay, listen, we can't be deployable this sprint because we couldn't run all the tests. Now, this is a breach of the rules. Right, you're going to break the rules, but there's some reason that you're going to break the rules, and it's a legitimate reason. Has anybody seen the videos I do on cleancoders.com? Who's seen those videos? Lots of you, okay. And you may have noticed in those videos there's 2 different kinds of videos. There's the clean code videos where I go through all these rules and principles and patterns and all this stuff, and I preach it just like I've been preaching to you, and this is the way you do it, and you got to do it this way, otherwise you're unprofessional idiots. And then there's another branch. These are the case study episodes, and this is where I sit down, or some other people sit down, and they actually write code. And the code we're writing is actually fairly significant. So it's several hours of watching us write this code, but what you will find in those case studies is how we break the rules, because we always break the rules. The case studies show pragmatic application of the rules, and we try to hold to those rules as much as we can, but you will find in every one of those video streams, there's times when we just look at each other and say, okay, well, can't follow the rules here, we're going to have to fiddle with it and judge it, and we'll come back to the rules as soon as we can. Happens all the time. So here I've been preaching to you for 2 days about all these rules, and I have to do everything right, and the best way to go fast is to go well. And then you always have to remember that this is engineering. And there's always trade-offs. There's always. Now, I don't want anybody to use that for a license and say, oh, well, Uncle Bob just said we can make a mess. Because you try as hard as you can, but the rules sometimes just cannot hold all the time. So, violate the rules. There was one more question here, and then we'll be done.
Yes, hi.
Good.
Hi. Okay, it's my question apparently. So earlier you mentioned that analysis is what analysts do.
Yes.
You just mentioned business analysts, and I have a lot of business analysts in my department. And I was wondering how would or how should they relate to an Agile team? Or maybe phrased differently, can or should they work in an Agile team?
Business analysts. It's one of the hardest jobs there is to be a business analyst, because to be a business analyst, you must be technically astute enough to talk to programmers, and you have to be personally astute enough to talk to the business side. There aren't a lot of people that are like that, who can turn both directions and communicate well across that boundary. Not only do you have to communicate well across that boundary, you also have to be accurate. You have to be able to put yourself in the position of the customer and understand what the customer needs so that you can communicate requirements to the software development team. But then you have to be able to put yourself in the programmer's position and understand what they are fighting against and how they need design and they need architecture and they need tests and they need rigid specifications. So it's an extremely difficult role. Every sprint team needs someone who can play that role. On small sprint teams, it is the product owner. On larger teams or in larger organizations, the product owner will usually have many teams that they serve, and they will delegate that role to product analysts, to business analysts. That's the way I define business analysts. That's how I would say it. So, did I answer your question?
Yes, thank you.
Okay. Been 2 days. And it's not often that I get to have an experience quite like this one. This has been unique. There's been a lot of work done here. A lot of work done. The videos, you know, and the look at. Did you notice how well everything worked? Right, and the schedule of things and how, you know, the breaks were set up and the lunch was set up and the timing of things, and it came in and everything worked and it was a nice, easy flow. That takes a lot of effort to make something work like that. And then you've got me, and I'm a complete prima donna because I wander around the stage and I break all the rules about, you know, you're supposed to stand in one place when you talk, you know. And I do all this stuff, and everybody has been just as nice about this as can be. I feel as welcomed as I have felt anywhere. You guys have been a terrific audience. I just want to say thank you to all of you, and thank you to you guys who did such great work. And I have been told that someone, beyond the recognition that everyone else has received here, someone here deserves a little extra recognition for being the point person on all of this. Can I have Kim up here? Is she here? These are not from me. I wish they were. But they're from your associates who really value you. So everybody, let's do that again, huh? Thank you all. It's been a great time. Take a break now. You know, it is hard to sit in a seat for 2 days and listen to some guy drone on forever. Thank you all.